In this tutorial, we will learn how to age market survey data using R. So you should have RStudio open, so let's go and make sure that we have a R script editor window open. In other words, an R script file window open by going to File, New File, R script. And I'm going to make a quick note using the hashtag here in which I'm going to say aging market survey data in R, which is the focus of this tutorial here. So we age data in order to bring it up to a point in time, either in the present or in the future, because at some point our market survey data was collected in the past. And so if we want to make projections about where those pay data, whether it's hourly or annual salary rates, where they are, we need to actually age those data into the future. So the first thing that we're going to do, as always, is we need to set our working directory. So I'll make a note of that here. I'll use the setwd function, set it to my H drive management, or rather my R workshop folder here. Click Run. Alternatively, you could go to Session, Set Working Directory, Choose Directory to select that in a different way using the drop-downs. The next thing that we're going to do is to read in the data. Now, the name of the data file is market survey data with a capital M for market, a capital S for survey, and a capital D for data. It's a .csv file, meaning a comma separated values file. So we're going to use the reader package, which is part of the tinyverse set of packages. And if you haven't already, or you haven't updated the reader package recently, make sure you do install.packages with reader in quotation marks as the sole parenthetical argument. Now I have recently installed the reader package, so I'm going to use the library function, and within the parentheses as a sole argument, I'm going to put the exact name of the reader function, which is all lowercase there, and I'm going to run that script there. Now I have access to the read_CSV function, which is what I'm going to use here to read in those data. So let's come up with a name for the data frame object that we're about to read in. And so let's assign that data frame to an object, and specifically let's call it MD for market data, and this is lowercase m, lowercase d. We'll use the left-handed arrow operator here so that we can indicate that we want to assign the values that we read in, the data frame that we read in, into this new object. And so again, we're going to use that read_CSV function from the reader package, and in quotation marks, put the exact name of the data file, which is market survey data, again with a capital M, a capital S, and a capital D here, and make sure you include the .csv and put it all in quotation marks there, and click Run. And so as you can see here, we read in the data. You'll notice that the first two variables are job ID, which is just the unique identifier for the job. The second one is job title. And then we have three survey 1, survey 2, survey 3. These are the actual hourly rates for the jobs that are going to be listed here. And then SS_survey 1, 2, and 3. Those represent the sample sizes, something we're not going to focus on in this tutorial here. In fact, in this tutorial, we'll just focus on the first set of market survey data from this source, which we'll call survey_1. So let's click on our global environment on the name of the object we just created, which is MD. And let's take a look at the data. Again, job ID, job title here. And then here, these are non-exempt jobs. These are the hourly rates here. So this would be $14.11 per hour. And let's assume that this represents from this market survey, the salary survey, this pay survey that we are working with here, that this is the median hourly, it's the median hourly pay rate for this particular job, as they have surveyed a number of organizations and a number of people within those organizations. Data has been provided to the survey vendor here. And so for packaging operator, we have $14.11. And for machine operator, $15.90, and so forth and so on. Again, we're just going to focus on this survey source here. So you can imagine this might belong to a vendor, Watson Towers or something like that, where you can get your market survey data. This is just an example here. And then survey 2 might come from a different vendor. Survey 3 might come from, who knows, like a federal information or federal data on market pay data and so forth. And so let's just focus on survey_1 here, and we will age those data. Okay, so we're going to use a 4-step process here in order to illustrate how to age the data. So as the first step, step 1, we're going to need to identify the annual wage or salary budget growth projection. Okay? And so this simply means is how much do we expect the wages, the pay to grow over a given year in the future. And so this could be due to merit-based increases, cost of living adjustments, things like that. And so there's different ways you can find these estimates, but commonly you might go through a reputable vendor like World at Work in order to find what the expected budget growth projection is going to be for, let's say, the next year, the next calendar year, the next fiscal year. And so for our purposes, let's assume that it is 3.1% for the upcoming year. Okay, and so remember 3.1% can also be represented as a proportion here of 0.031, which is what we're actually going to be working with here in a second. So we're just going to do something very simple here, and we're just going to do very basic variable assignment, and we're going to assign that 3.031 to an object that we'll call ABG, where this will just be annual budget growth. And we'll use the left-handed arrow to do that assignment. And so again, just ABG, left-handed arrow, and then to the right of the left-handed arrow, 0.031. And so what you'll notice here, now we have this new object in our global environment, ABG, with that assigned to it. Now, what I'm about to show you, you could do all this in a single step, but I think it's helpful to break it down to understand what we're actually doing here. Okay, so for the next step, step 2, we are going to be dividing the ABG by 12. And so what this is doing is giving us our monthly growth projection. Because remember, this is an annual growth projection of 3.1%. So how do we break that down to a monthly growth projection, which if you're trying to age your data, anything other than full year increments, this is what you'll need to do, is to break it down into what is the expected monthly growth projection. And this will become more apparent in a second here. And so this is a really easy step here. We're just going to create a new object here. Let's call it MBG for monthly budget growth. Use the left-handed arrow operator again, and just do ABG, which is your annual budget growth, which is again 0.031 that we specified above, and then divide by 12. So divide by 12, there's 12 months in a year. That's where that comes from. And let's click run there. And so here you'll see MBG, the monthly budget growth here is 0.0025. And so you can see it's a fairly small number here. And but this would be what your monthly growth projection is here. Okay. All right. The next step is step 3. And in this step, this is where we're going to actually determine what our aging factor is. So we're going to calculate our aging factor. And to do so, let's create a new object. We'll call it AF for aging factor. Use the left-handed arrow to assign values to it. And what we're going to do is we need to come up with how many months do we need to actually age the data. So let's assume that these data, the survey vendor for survey_1, they published the data 6 months ago, or the data were 6 months old as of today. So that would be 6 months. But let's say we plan to implement these changes in pay potentially a month into the future from now. So that would be 6 plus 1. So 6 plus 1, put a little note here, 6 plus 1 equals 7 months. So we need to age the data by 7 months. Okay, and you would come up with whatever rationale or whatever length of time you need to age the data. You'll have to come up with that figure, the number of months that you need to do so. And so here I'm putting in parentheses, I'm going to put our monthly budget growth, which we calculated here, which is that value of 0.00258, etc., and multiply that by 7, because remember, this is now a monthly budget growth here. Multiply it by 7 months, and then we're going to add 1 to it, the integer 1. And so why are we doing that? Well, this is expected growth. And so when you're trying to establish growth, you want to multiply our aging factor by existing hourly pay data in this case? Well, we need to add 1 to it so that we have a value that's greater than 1, which will indicate growth. If we didn't have the 1 there, it would actually indicate decline in the overall estimates of hourly pay as time goes forward. Okay, so watch what happens here when we run this. Okay, now we have a new object here, and it is 1.018. Okay, so this is our aging factor here, 1.018. And again, we estimate that by, or rather, we use the AF object here to indicate that. Okay, so now we are ready to move on to step 4. And so for step 4, we're actually going to age the data. Okay? And so this is relatively straightforward. We're just going to multiply our existing data. In this case, it's all the data from this column, this variable for survey underscore 1 here. And we are going to multiply it by our aging factor. But first, we need to come up with a new variable name for these age data. And so specify the name of your data frame object, which is MD in our case. And let's name this, let's say survey 1, and then just add an underscore age to indicate that these data were aged here. We'll use the left-handed arrow to assign values to this new variable that we're creating and adding to our MD data frame. And then MD again, $, and then the name of that market survey data variable, which is survey underscore 1 in this case, times, using the asterisk there, the aging factor that we created, that object that we created above, which was capital A, capital F. Okay? And so watch what happens when we run this. If we come to our data frame object here, we now see we have a new variable here, which is our age data. So you can see for survey 1, originally for the job of a packaging operator, it was 1411. Now if we age it into the future, 7 months, we get 14.37 about. Well, because these are dollar values, let's go ahead and also round this as well, just to clean things up. And so to do so, let's just copy the name of this variable here. We'll overwrite the existing values, and we'll use the round function from base R, and we'll paste in the exact same, let's get rid of that left-handed arrow there, the name of our new variable, which is survey underscore 1 underscore aged, and as well as having the $sign here, MD, to say that it belongs to that MD data frame object. And then let's do comma, and as the second argument in the round function from base R, enter the numeral or the integer 2. And this will signify that we want to round to 2 places after the decimal point, which is typically how we do it when we're representing dollars or currency in many cases. Okay, so let's go ahead and run this. And what you'll see now is if we go to our data frame object again and take a peek, you'll see that now we have rounded to 2 places after the decimal, and here we have that updated in this column here. So this is all that it takes here to age the data. Now, more than likely, you'll have to age different survey sources, market survey sources, by different aging factors. And the reason being is that often different vendors publish their findings at different times, they collect the data at different times, and so you'll need to adjust this accordingly. So the aging factor for survey underscore 2, this market survey source might be different than survey underscore 1, and the same goes for survey underscore 3. But in a nutshell, this is how you age your data, and specifically how you age market survey data in R. Now, there are other ways in which you could do this more efficiently. You could do it in a single step by collapsing all of these into one step or one equation. But in this case, I thought it was helpful to break it down to this 4-step process. So this wraps up the tutorial on aging market survey data in R.